Hello and welcome to Global Math Mentor. Today we are solving the full IB Applications and Interpretation HL Paper 1 from May 2025, step by step, exactly like you should in the real exam. I'll show you the fastest methods, common mistakes to avoid, and the calculator techniques that can save you marks. If you're preparing for your finals or retake, this is a paper you should practice with me. Let's begin. Before we begin, quickly pause and read the instructions if you want. But the important thing here is IB is clearly saying that answers alone are not enough. You need proper working, explanations, and if you use your calculator to get a graph or solution, you still need to support it with written work. That's exactly how I'll be solving throughout this video. Question 1, it's a 9-mark question. 3 points NP and V are shown on the following diagram. NP is 20 meters, PV is 25 meters, and VPN is 55.5 degrees. Part A, find NV. Well, I should be solving on the answer space given on the next page, but since I need to look at the diagram, so I'm going to solve my question over here. But please do note well that you will not be solving on this page. So in order to find NV, I need to apply cost rule. This is a trigonometry question. So NV square is going to be 20 squared plus 25 squared minus 2, 20, 25, and cos of 55.5 degrees. So I will sub this in my calculator. First, I need to clearly check, is my calculator in degrees or rate? Thank goodness it's in degrees. Always check your calculator. Since the angle is given in degrees, you should be in degree mode. 20 squared plus 25 squared minus 2, 20, 25, and cos 55.5. This is the answer, and I need to square root my answer. And I'm getting 21.4148, 21.4148, dot, dot, approximately 3 sig figure, 21.4 meter is my answer, right? Part B, find PNV. We can see this is PNV, and this is a sine rule application question, okay? So how do we apply sine rule? Let's go. For part B, I can do sine P and V. You can maybe call it just N or theta or X. You can suppose it anything, but I'm just using the original name, P and V. And divided by the facing side. How do you apply the sine rule? If you apply sine on angle N, you divide it by 25. And what's the second angle? It's sine of 55.5 degrees. And I divide it by the facing side. Now, this is the part which I want my students and every one of you to be very careful about. What students do here, they put the 3SF rounded one, and that causes a premature rounding error. Don't use that. Instead, use the unrounded 21.4148 dot, dot, dot. Look now how I will use my calculator in a clever way. So I've got this answer written over there. So I will do sine of 55.5 and divide by shift, let's say answer. So I'm using all that big number like the 9 decimal value of that answer. Execute. And now time it with 25 because I need to cross multiply. And now since this is equal to sine P and V, I can do shift, sine inverse, and answer. And I'm getting 74.1749, 74.1749, and dot, dot, dot. But angles can be given correct to 1 decimal place. So this should be my answer, right? Part B. So hence or otherwise find the shortest distance between P and NV. So what is the idea of the shortest distance? Shortest distance between P and NV will be a perpendicular distance. So you can make a line like this. Remember, we are not solving it by construction. We will be using trigonometry to solve this. So this is the shortest distance. Let's just move it a bit up, and for part C, do you want me to? Okay, let D be the shortest distance. So I called it D. Now look at this triangle, this one. It's a right angle triangle. So I can go for SOHCAHTOA, right? So what ratio do you think so I can apply? So I've got this angle, which is again, don't use 74.2, instead use that angle. So I'm going to use the sine ratio, opposite over hypotenuse, sine 74.1749. Remember, I've got this answer in my calculator, so I can use the same one, equals to opposite over the hypotenuse. Cross multiplies, so D is going to be 20 times the answer. And let's see, what do we get? Okay, so I've got this value. Just do the sine of the answer. And I can time that with 20. And this is going to be 19.24 197, 19.24197, which can be given 19.2 meter. Question 2. It's a 5-mark question. The loudness of a sound L measured in decibels is determined by the intensity of the sound I. So we have L, which is the loudness. We have I, which is the intensity, measured in watts per square meter. Okay, the relationship between loudness and intensity can be expressed using the logarithmic function. It's given I is positive, where I naught is the reference intensity, the intensity of the least audible sound to the human ear. So it's kind of a fixed thing, the reference intensity, right? Okay. The intensity of the sound on a busy street is this. So let's see. Part A, calculate the loudness of the sound. So to do part A, we just need to substitute. We need loudness, which is L, 10 log 10. And in place of I can put 10 to the power negative 5. And in place of I naught, I can put 10 to the power negative 12. This is going to be 10 log 10. I can use indices to get 10 to the power 7. We know that since bases are same, we can subtract the powers. Now, for the newer versions, TI-84s and the Casio's latest versions, you have log base something button, but this is an older version. I can use base 10. I've got a separate button for log base 10, which is this. So I can put 10 to the power 7, and that's just going to be 7. If you know logarithms, since the base and the domain's base is same, so the power, from the power law, we know this is just a 7. I can time this with 10. But even if you don't know this property, you can just straight away use the calculator to get it. But I encourage you to recognize log rules. Some of them are given in the formula booklet as well. Okay, so this is going to be 70. And since it's the loudness, I can write in dB decibels, right? Okay, part B. So they're saying the sound of a jet engine reaches a loudness of 185. That is L. And they're saying determine the intensity of its sound, give your answer. This is the standard form thing, a into 10 to raised to power k. K should be an integer and a should be within 1 and 10. So let's go. I can either use just the analytical approach or the graphical one. I usually liken these log questions to use the analytical approach, but I'll give you some idea about how you can use graphs to find. Normally, the problem that students face with these kind of questions is when they graph it, they mess up with the viewing window thing. So you need to set it, just experiment, play around with the viewing window. Okay, so I naught is the same value because that's the least audible sound to the human ear. So it's a fixed thing, 10 to the power negative 12. Okay, and I need to find I. Let's apply this in the function given, logarithmic function. 185 is going to be equal to 10 log base 10, and I we need to find, and 10 to the power negative 12. So let's reverse this. So 185 divide 10 is going to be 18.5. And I'm getting log base 10. Now there are a lot of things I can do with this thing, but the best thing is like change back to exponential form. So 10 to the power 18.5. I encourage you to just focus on the log rules. That's what I'm using. Okay, so I divide a 10 to the power negative 12. Now I've got to be careful because I need to give this answer the standard form. So I is going to be, this implies that 10 raised to power 18.5 and minus a 12, right? Okay, so that's going to be 10 to the power 6.5, right? And that is not a standard form number. Okay, so what did I just do? 18.5 minus a 12, and that's a 6.5. So in order to make it a standard form, your power should be an integer. So you might be thinking, how do you switch it into a standard form? So the best thing I can show you right now is just separate the 6, which is an integer, and separate the 0.5, which is a decimal number. And you can just put this in your calculator and you'll get like a normal decimal value for this. 10 to the power 0.5 is going to be 3.16227. 3.16227 into 10 raised to power 6, which can approximately be given as 3.16 into 10 raised to power 6. There we go. Question 3. It's a 7-mark question. Prakash is the leader of a customer service team and is interested in determining whether there is a relationship between a customer's satisfaction level and the type of service interaction they have experienced. Service, interaction. He collects data from the random sample of 250 customers and tracks their satisfaction level after 3 types of service interactions: in person, online, chatbots, and website contact forms. He categorizes the satisfaction level as satisfied, neutral, and dissatisfied. We can see this in the table: satisfaction level, type of service interaction, in-person, online chatbots, website, contact forms, satisfied, neutral, dissatisfied. He records the data in the following table, and this is a contingency table. Prakash, yes, performs a chi-squared test for independence at the 5% significance level. The critical value is given 9.488. Okay. So the null hypothesis H naught is already given. Is the satisfaction level and the type of service interaction are independent. So H naught is always independent in chi-square test for independence. Part A, state the alternate hypothesis for this test. So for H1, you will write satisfaction level and the type of service interaction are not independent. Sorry about my writing, but remember, H1 is always the alternate hypothesis, and H1, it says that these sets of variables are not independent. All right, so part B, find the degrees of freedom for this test. Now, one way of doing this is just feed the data into the matrix, and I will be doing that to get my chi-squared value, the next part. But there's a direct way, a formula you should learn. So for part B, you can know the degree of freedom is like a row minus 1 times a column minus 1. So we know that there are 3 rows and 3 columns. So this is going to be 3 minus 1 times a 3 minus 1. Again, note well, the degree of freedom is 4, but later my GDC will tell me the degree of freedom as well. Okay. So in order to calculate the chi-squared test statistic, I need to find that chi-squared value. Now follow these steps, right? First of all, you need to put the matrix. Okay. So in the matrix, let's just execute, and it's asking for the dimension. Put a 3-row and 3-column, and it will show you this matrix. Feed the matrix 35, 30, 23, and this is 31, 39, 23. Okay, the last row is 19, 28, and 22. Oh, 22, right. Okay, let's quickly check. Have I entered the values correctly? Okay, now this work is done. Now I will go to menu and go to stats, go to test and the chi-squared. In the newer versions of the calculators, you get the goodness of fit test as well as the 2-variable test. So you can check. There is another video. I'll share the link in the description where I have explained in detail how to apply the chi-square test for independence. But right now, this is just a solution video. You can follow these steps. Okay. So everything is there already. I just need to execute. And I'm getting my chi-squared value, you can see there, and the probability is there as well. And the degree of freedom, as I told you earlier, DF is given, that's 4. Okay, so my chi-squared value is 3.3191. 3.3191. I just rounded it, but you know it's a bigger value. So you can give your answer correct to 3 significant figure as 3.32, right? Okay. Now comes the next part. They're saying Prakash concludes that there is sufficient evidence to reject the null hypothesis. So he's saying there's a sufficient evidence to reject the null hypothesis. So part D1, state whether Prakash is correct, justify your answer. So for part D1, there are 2 ways of accepting or rejecting the null hypothesis, right? So first of all, you can see that my chi-squared value is less than the critical value. So this is one way. When your chi-squared value is below your critical value, you do not reject H naught. There is insufficient evidence to reject H naught. So we cannot accept the alternate hypothesis. Or there is another way, like you can check it's a 5% significance level. So check your probability. It's a 0.05059. 0.05059 is bigger than 0.05. Hence, since your probability is above the significance level, even this is a sign that H naught will be accepted, right? So you will say, state whether Prakash is correct. No, Prakash is incorrect. Or you can say he's not correct, right? So these are the 2 reasons. Let's do the second part. They're saying write down the conclusion for this test in the context, as I already mentioned. So you will say that there is either you can say insufficient evidence to reject H naught. So you can write the context of the question. So what's the context? You can say that satisfaction level and the type of interaction are independent, right? Question 4, it's a 7-mark question. The times in seconds for the fastest 16 women in a 50-meter freestyle swimming championship event were recorded. All swimmers recorded different times. Part of the box and whisker diagram for these times is shown in the following diagram. So we can see that the box and whisker diagram has not been made completely. We can see there is a median. This must be the upper quartile and this must be the lower quartile. So remember, box and whisker diagram, the middle 3 lines, what do they mean? Okay, part A. Write down the number of swimmers who took more than 24.7 seconds to complete the race. So let's see. Oh, I can check. So look at this thing. Your quartile 3 is 24. 24.7, right? So they are saying more than 24.7. So quartile 3 or the upper quartile is like the 75th percent of the data. So there will be 25% values above Q3. Okay. So let's just get 25%, which is a 0.25 of 16. You can do it this way as well, like a 1/4 of 16. So that's going to be 4. So they're saying write down the number of swimmers. There will be 4 swimmers. This is part A. All right. Find the interquartile range IQR for the data. We've got the upper quartile. Let's take a look at the lower quartile. So I got to be careful with that. This is 24.2 and this is 24.3. So there's a gap of like a, all right. So, I mean, there are ways in which you can do it with the calculator as well. If you don't want to do it mentally, you can do it this way. Like, take a look at this. You can do 24.3 minus a 24.2. And if you divide it by 5, you'll see like a 0.02. So I know that one of the lines represent like a 0.02. So the first line is going to be 24.22, 24, 26, 28. So this is going to be 24.28, quartile 1. Why am I doing this? Because I need the interquartile range. So interquartile range is going to be 24.7. Take out 24.28. So I'm going to use my calculator, 24.7 minus the answer. Oh, it's no answer. 24.28. So I'm getting 0.42. This is part B. All right. So they're saying an outlier is defined as the value that satisfied one of the following. So, this is a crucial part of the statistics course in the IB application. There's a lot going on with the outlier thing. Most of the time they give it in the question, but I think I've seen some questions where they haven't mentioned this. Just know any value like 1.5 times you do the interquartile range, you add it to Q3 and you subtract the same factor from Q1. Any value which is below this and any value which is above this is going to be the outlier of the data. All right. Okay. So they are saying of the 16 women, the 2 fastest swimmers took 23.96 and 24.12. So these are the smallest times, right? Because they are fastest. Seconds, and the 2 slowest women took 25.12 and 25.40 seconds to complete the race. Part C, 1. Show that only one of these times is an outlier. Okay, so for this, I just need information from here. So one of these times, I need to check what is Q3. Yeah. Okay, so part C, 1. Let's do 1.5 times interquartile range, 0.42. And add it to Q3. So Q3 is 24.7. And let's do 1.5 times interquartile range and subtract it from Q1, which is 24.28. Let's get these calculations and see what do we get, okay? So you can take notes side by side as well, like make sure you know what am I doing. And you can always type in the comment if you have any difficulty with what I'm explaining right now, okay? Now I'll make sure I'll answer you as soon as possible. 24.7. So I'm getting 25.33 for this value, 25.33. Okay, and let's see what do I get for the next one, 24.28. Subtract a 1.5 times 0.42. And this is 23.65. 23.65. All right, so both of the smallest times is above. You can check that 23.96 is greater than 23.65 and 24.12 is definitely greater than 23.65. So no outliers here, right? No outliers. All right, so if I check the next one, oh, I've got one, right, for the uppercase. So you can see that 25.33 is greater than 25.12. So no outlier here as well. But you can see that 25.40 is greater than 25.33. So this 25.40 is the only outlier, right? You got it, right? That's the only outlier out of these 4 times. Part C2, complete the box and whisker diagram. Okay, since these values, smallest times are not outliers, so they will be part of the data. So let's go to 23.9, 92, 94, 96. So this is going to be, oh, my eyes hurt. That's the smallest time, okay? Let's mark it over here. This is 23.96. And what's the max time? I don't need to put 25.4. Let's just put it over there, but this is not going to be that. That's just an outlier, 25.4, right? That's the outlier. But I need to put the biggest time, which is part of the data. That's going to be 25.12. So that is this time, okay? So in your exam, like you can use a scale to complete it. My annotator just doesn't give me like a nice line, but I'm trying. They're not supposed to be curves, they're supposed to be straight lines. And that's it for this question. Question 5. This is an 8-mark question. Sophia takes out a loan of 50,000 euros. She pays a nominal interest rate of 4.2% per year, compounded monthly. She must pay back the loan in 25 years through regular monthly payments made at the end of each month. Okay. Part A. Find the amount Sophia must pay back each month. Give your answer correct to 2 decimal places. So we have the principal value for part A, which is 50,000. And we have the interest percentage, which is a 4.2. We know that it's compounded monthly. So CY is 12. She must pay back the loan in 25 years. So N is 25 times 12 since it's a monthly payments. So PY is going to be 12 as well. I'm just collecting my data. So 25 times 12, you can do it like a 300 payments she need to give, right? Okay. So what else is there? We need payment, right? The monthly payment. That is what we are looking for. Okay, now there are some things which should be kept in mind. Like if you give your principal value or the present value as a positive number, you will get your payments as negative number. Don't get confused by negative. It means like something is going out of your pocket to the bank. You are paying back the loan. So if you take that as a negative, you'll get this answer as a positive. Let's go to the menu and TVM time value money feature. If you are not good with using GDC in these financial math question, I've got a separate video on that. I will share the link in the description. You can watch out that later as well. Okay, so go to this F2 compound interest feature on your Casio. Here I'll just put it 300. I can either put 25 times 12, doesn't matter. The calculator is going to calculate that value itself. Put a 4.2. And remember, like just like they say at the end of each month or the starting of each month, so you can try shift setup and you can see the payment method is already by default set to end, but you can make it beginning as well. Like it depends on the question, but most of the time, like it's always like the end of the month. So the present value is 50,000. All right. And payment we are looking for, future value doesn't need. Rest, the information is correct, right? Okay, so you will get now your answer for the first part as a negative number. You'll see that. Okay, so that's 269.47. Well, I need my answer correct to 2 decimal place, so I can write 269.47. 269.47. But remember, you can give the unrounded answer first, and then you can round it to the given degree of accuracy, right? Okay. At the end of 8 years, Sophia wins the lottery and pays back the remainder of the loan early in one single payment. Part B1. Let's see. So she won some money and she paid back in 8 years. Find how much Sophia pays back in this single payment. Give your answer correct to two decimal places. Okay. So after 8 years, so still the principal value is 50,000. Principal value. The interest percent doesn't change. That's 4.2. Okay. Percent. The compounding is 12. The payment per year is 12. Just collecting my data. Okay, so n is now going to be 8 times 12, right? So make sure you make that. Okay, and look at this because it's a monthly payment system. After 8 years, she pays back. So we are looking for the future value this time. And you need to put your monthly payment to 269.47. So let's just feed these values in the calculator again. So I need to change my n, which is 8 times 12. You see, you can just put 96 over there. And this, I would encourage you make it minus 269.47. So the reason being, since the previous answer was already given, sometimes they say give your answer correct to the nearest dollar. Then you put those values for the correct answer. It depends, right? Okay, so rest of the information is okay. And I just need to press the future value. So the future value is 39243. 39243 point. This is again a two decimal number. So 42. That is the future value, and that should be my answer. So this much she will pay immediately, right? Okay, part B2. Find the amount of money saved by Sophia by paying back the loan early. Okay, so let's see what just happened. She was supposed to give 25 payments of monthly payments of 269.47. Okay, so let's see how much she originally had to pay. 25 times 12 times 269.47. So 80841. 80841. This was like the complete payment. Okay. And instead, how much did she pay in those 8 years? 12 into oh, my bad, sorry. She paid 8 payments of 269.47. Let's make this 8 times 12 times 269.47. So she paid this much in 8 years, 25, 25869.12, 25869.12. Okay. And also, plus she cleared this much immediately, 39243.42. So let's see how much saving. The saving is going to be by paying earlier, 80841 minus, add these two, 25869.12 plus 39243.42. Okay, so I just need to add 39243.42 and subtract this whole thing from 80841 minus the answer. And I'm getting 15728. 15728.46. And that is the required saving. Question 6. It's a 6-mark question. A circular disk has 10 white sectors and 10 shaded sectors. This is the disk shown. The size of the angles made at the center of the circle by the white sectors form an arithmetic sequence. All right, so that's an arithmetic sequence. The common difference of this sequence is 3. Okay, I'm going to do the part A. D is 3. And the first term is 6 degrees. These are angles, right? So angles are forming an arithmetic sequence. So U1 is 6 degrees. Okay. An arrow is attached to the center of the circle as shown in the following diagram. The arrow can be spun and has an equal chance of stopping at any point. All right. So every situation is like equally likely. Part A. Find the probability that the arrow will stop in a white sector. All right. So in order to find the probability, first we need to find like what's the overall chance of landing on a white sector. So let's get the sum of all the angles, right? So how many sectors are there? There are 10. So n is 10. I'm going to find S10 so that I can find the sum of all the angles in the white sector. Okay, you'll see what I'm trying to do now. Okay, so 10 divide 2, that's the sum of an arithmetic sequence. And it's going to be 2u1, which is a 6, plus n minus 1, 10 minus 1. Okay, let's just write 10 minus 1. And into d, which is a 3. Okay, the formula that I'm using, you can check in the formula booklet, the sum of an arithmetic sequence. So it's going to be 5 and 12 plus 27. Let's get this. What is this? And 12 plus 27 and times of 5. It's 195, right? Okay, now what will be the probability? Since the white sector's total sum is 195 and the circle, was the sum of all the angles? It's a 360 degrees. Now you get it? Why I was trying to sum the angles of because the arithmetic sequence is formed by the angles. So we do 195. Let's give it as a fraction, like, okay. So 13 over 24. That looks like a nice answer. 13 over 24. So that's the answer to the part A. Okay. Oh, okay, I'm going to share it once again. I did it in the start of the exam when I started it. We're not supposed to write in these spaces. We will, in your actual exam, you should write in the answer space given, but I'm just solving it for the purpose so I can see the diagram straight away. I don't need to scroll again and again. Okay. Next part, right? In a game, the arrow is spun 4 times and the player wins if the arrow stops in a white sector at least 3 times. So stopping at a white sector has a fixed probability, and now we have a constant probability, fixed number of trials. So where does it lead to? So if you have practiced binomial distribution, you know these are the situations for a distribution to be a binomial. If the parameters are the fixed number of trials, that is n, 4, and the probability of success landing on a white sector is 13 over 24. So they're saying in a game, the arrow is spun 4 times and the player wins if the arrow stops in a white sector at least 3 times. Okay. Find the probability that player wins the game. So we need the probability x at least 3 times. Some of the latest calculator do the right and the left thing in the binomial, but just like normal. But mine doesn't, and most of the calculators do not. So what's less than 3? That's the complement of more than equal to 3. But since it's a discrete distribution, so I will write less than equal to 2. So for this, you need to check out binomial distribution. 1 minus, how do you get this part? Okay, so I go to menu, stats, distribution, binomial, and go to CD. Since this is an inequality, choose variable. X is 2, num trial is 4, the fixed constant probability of success is 13 over 24, and let's execute. And I'm getting 0.6225, let's say 5. 0.62255. Okay, so let's get this. And 1 minus 0.62255. I'm getting 0.37745. 0.37745. And my answer, 3 significant figures should be 0.377. Question 7, it's a 7-mark question. A team of researchers is using a model to predict the relative happiness of different countries. To do this, a value of X is calculated based on easily measured parameters. For example, life expectancy or available social support. It is assumed that higher values of X indicate greater success. So higher values of X means greater happiness. Okay. To test the model, a survey is conducted in 6 countries, A to F. In these countries, the level of happiness is assessed directly using questionnaires and given a score by out of 10, with higher scores indicating greater happiness. Okay. To select the countries for the survey, all countries are divided into 3 equal groups based on wealth, and 2 countries are chosen randomly from each group. Part A, write down the name of this type of sampling. All right, so we need to check like divided into 3 equal groups. So the quantity is taken into consideration, the ratio. So whenever you divide groups with equal ratio and then you select from these on the basis of like wealth and 2 other countries are chosen randomly, this is the method known as the stratified sampling technique, right? So this is the name of the sampling type. All right. The result of survey along with the values obtained from the model are given in the following table. Countries are given, value of the model X is already given, happiness score is already given, right? The researchers will accept the model is a valid predictor of happiness score if the Pearson product movement correlation coefficient R is greater than 0.8. So B1 is find the value of R. Let's go. So how do we do this? We go to stats and we just feed in these values in the table: 12.3, 15.2, 14.1, 18.5, 20.1, and 19.2. Okay, and let's go. The other part is 5.2, 7.3, 6.2, 6.9, 8.0, and 7.2. Okay. So then we go to calculate and this REG regression, right? Go here and just go for the linear one since you're using the linear regression here. So this is what I'm getting. And you see that there is a value of R given, which is 0.853899. 0.853899 dot dot dot. So approximately you can get 0.854. And since this value is greater than 0.8, they're saying part B2, hence state whether the model can be regarded as a valid predictor of happiness score. So you will say since 0.854 is greater than 0.8, yes, the you can say the model is valid, right? Okay, part C. Find the equation of the regression line y on x. So this is the part I want you to note carefully. You need to give all these possible values if you can try like, because you know when I start writing, my calculator just goes away from the screen. I don't know, that's a problem. Okay, so 0.266. I'm just writing the 3 significant rounded ones. Oh, but definitely I need the bigger values to calculate the next part, right? So 0.26585. 0.26585. What is this? That's the value of the slope, right? 85, and let's keep 102 as well, right? So that is x plus what is the b value, which is like a y-intercept of the model, 2.3957, 2.3957, and I can note down 3475, 3475. Okay, that's it. So you can give your final answer as a 3 sig rounded one, but do use the unrounded, like the bigger values, to accurately find the next parts, right? So this is part C. For a particular country, X is 17.2. Part D. So they're saying use the regression line to predict the happiness score for this country. Okay. So now we need to sub in for part D. We need to sub in x equals to 17.2. So let's go. X is 17.2, but you see, I'm going to put it here in this unrounded one. So y equals to 0.265855102, 17.2 plus 2.39573475, right? Let's get this in the normal calculator. So 0.265855102 times this is 17.2 and plus 2.39573475. Okay, let's go. It's 6.9683 something. So I'm going to give my answer 6.97 for part D. But you will obviously round the first write the unrounded answer and then round it, right? Question 8. It's a 5-mark question. The matrix 0110 transforms a point A to a point B. The matrix 3011 transforms the point B to the point C with the coordinates this. So they're saying find the coordinates of A. So what's going on? First of all, 0110 is being applied to A, right? And this becomes a B, right? This whole thing becomes a B. Then another matrix it's being applied, which is 3011. And that transforms this to C. Now we've got the coordinates of C. We can write it as a column vector, or you can say a column matrix for 7. So let's do the product. You can either use your GDC to get the matrix product. You know how to do that. But I'm just going to be, since it's a 2 by 2 matrix, I'm just going to do it manually anyway. So 3 goes with 0 and 1. So first element is going to be 1. 3 times 1, 1 times 0, that's a 3. 0 times 0, 1 times 1, that's a 1. 0 times 1, 1 times 0, that's a 0. Okay? And we can say, let's say A is some column matrix XY. So, like the matrix multiplication order, if this is a 2 by 2, this has to be a 2 by 1 to get a 2 by 1. And in any case, since they're asking about the coordinates make a 2 by 1 matrix, right? Order is 2 by 1. All right, so let's multiply again. X plus 3y, that's how you time it. And x plus a 0y, so that's just going to be x equals to 4 and 7. Let's equate the members. So from the y, the lower part, we can say that x is 7, right? And x plus 3y is going to be 4. So 7 plus 3y equals to 4. 3y is going to be negative 3 and y is a negative 1. So A turns out to be 7 and a negative 1. These are the coordinates of A. Question 9, it's a 6-mark question. Consider the curve y equals to 4x, a root of 3x minus 2, and the domain is given. It should be more than equal to 2 over 3. Okay, so it's a calculus question, part A. Find the derivative dy over dx. So for this, the HL students need to be familiar with the product rule, since this function is a product. So if you differentiate, you will differentiate, let's say, 4x, the derivative is going to be 4, and keep root of 3x minus 2 as it is, plus 4x now, leave it as it is. And this expression is differentiated using a chain rule, right? So how do you differentiate it? First, the power property, half 3x minus 2. A half minus 1 is a negative 1 half. And now you need to multiply with the derivative of the base function, which is the inside bracket thing. So time it with 3. And this is the chain rule, right? Look for chain rule if you have become rusty or something, or you haven't practiced it lately. Okay, 2 double. I'm just going to simplify it as far as possible. 3x minus 2. It's always good to simplify the final answer. It helps you in the next part. So 2 times with the 3 and x, and I can, yeah, I mean, it's not necessary, but I have a habit of writing as a positive index, so I'm just writing it this way, right? I mean, any equivalent form will be acceptable. You can either give it like 3x minus 2 to the power a negative 1/2, right? Oh, okay, let me just write it so you don't get confused. 4 root of 3x minus 2 plus a 6x times a 3x minus 2 to the power a negative 1/2, right? Both are correct answers. Part B. Application of calculus, equation of tangent to the curve at the point is. So first we need the gradient of the tangent line. And how do we find it? We substitute this x value of this coordinate 6 into the derivative. So 4 root of, what is this? 18 minus 2, that's a 16, plus the 6 times 6 and divided by a root 16. I mean, I want to use a derivative, the calculator, but this is just going on without a calculator, so I'll just solve it. So that becomes a 16 plus 36 over 4. That's going to be a 9. And I'm getting a 25. And you can see the next part. They're asking for the show that the equation of tangent. So the gradient is clearly 25. So I've proved it in my working. I mean, you should be using a calculator if you're not good with mental math. In this application course, the best thing is that you can use calculator in every exam, unlike the analysis exam where there is a non-calculator exam which students appear in. Okay, so I've got a point 6 and 96. Let's make the equation of the line. So I'm using a point slope form. Y minus y1 equals to m and x minus x1. So let's get this 25x and minus, I mean, it's 150, but let's just use some GDC. So you can see that that's a negative 150 and plus a 96. So y equals to 25x, and I can just add a 96 to it, and I'm getting a negative 54. So this is what I was trying to show. Question 10, it's an 8-mark question. A satellite orbiting the Earth experiences a gravitational force F Newton, which varies inversely as the square of the distance d kilometers from the center of the Earth. So F varies inversely, so it should be K, but square of d. This is a relation. When d is 7,000, F is a 40,000, part A1. Find an equation for F in terms of d. So we will just substitute 40,000 for F and 7,000, but I need to square it. So it's going to be a huge number. Let's see. Most of the time, the calculator just gives a standard form answer if the number is too huge. 7,000, and let's square it. Yeah. Okay, so K is 1.96 into 10 raised to power 12. That's the value of K. So I'll write my final answer. I need to write the relation F in terms of the F is going to be 1.96 into 10 raised to power 12 over a d squared. There we go. Okay. So the second part is saying find the value of F when d is 3,500. So I just need to substitute the value 3,500 and square it. I've got the value in the calculator, just do 3,500 and square. And I'm getting 160,000 for this part, right? Let me just check. Right. Okay. So let's see the next one, part B1. Identify which two of the following graphs would form a straight line. We know the linearization process. You've done that in logarithm. Like normally when you apply log, you can convert exponential functions to linear form. What's a linear form? Like y equals mx plus c. There should be a pure constant, a pure variable, and a combination. So keep that in mind. So part B1, I'm going to test these relations. F against d. No. Because I can see my relation is this thing, 1.96. Let me just form it in a linear way. So this looks one possible linear form. You can see that this should be the gradient in d to the power. Oh, this works. Come on, part C, it works. F against d,
minus 2, because you can see that the gradient terms in the next part, I think they're asking for the gradient. So C works. And for the second part, we can say that the gradient gradient 1 will be a 1.96 into 10 raised to power 12, right? Yes, I'm doing both parts in the same way. Okay. Logs work, but let's see which one works, D, E, E, F. Normally, we apply log to both sides, right? Because you can't just apply log to one side. So this goes. And here, if I apply log, the product becomes a sum, 10 to the power 12, and plus a log 10 and d to the power negative 2. Well, you can see this will turn out to be a C. And if you apply the power property, the minus 2 jumps in the start, and this is a linear form. Let me just rewrite it so you can see clearly. Log 10f. This will look like a negative 2 log 10d and plus a log 10 and 1.96 into 10, 12. So you can see that this is a C value, this is the X value, this is the M value, this is the Y value. So we have linearized this exponential function, which was given in the part A. So yes, D will work and E and F will not work, say, since they have log on one side. So what will be the gradient? The second gradient is going to be minus 2.
It's a 6-mark question. Consider the system given by the coupled differential equations. It's part of the calculus course on the HL application math. The following phase portrait shows the trajectory that passes through the point 1, 0. We can see it's the 1, 0 over here. And at time t equals to 5. Part A. Write down which one of the following could be an eigenvalue for the system. So I would encourage you all to learn the shapes of the phase portraits. So you must be familiar with the idea, like when it's a spiral, you have a complex eigenvalue. And since it's an outward spiral, your real part must be positive for the outward spiral. And similarly, for the inward spiral, the real part must be imaginary. They do not follow the pattern, the style of the shape of the complex eigenvalue. So C and D looks fine. And C will be the correct answer since it has a positive real part and D has a negative real part, right? C is the answer. Part B. Use Euler's method with a step length of a 0.1 to find the approximate values of x and y when t is a 5.5. So we use the recursion method for this. Let's see, how do we do this? Before we begin the Euler method, you must write your values like a tn plus 1 is going to be tn plus a step length, which is a 0.1. xn plus 1 is going to be xn plus a 0.1 times the rate of change of x, which is 3xn minus 2yn. And yn plus 1 is going to be yn plus a 0.1 times 4xn minus a yn, right? Okay, so let's go to the recursion. An plus 1, that will be treated as the t. So I'm going to put an plus a 0.1. For bn, I will put a bn plus a 0.1 times that derivative. So that's going to be 3bn minus 2cn. Okay, and cn, that is regarded as a y. This will be yn, which is cn, plus a 0.1 times this derivative, 4bn minus a cn. Okay, once these values are set in, before going into the table, always set your values. Like, what's the start? What's the end? Okay, so for the number of recursions, you can apply this idea since we are starting from t naught, which is a 5, to a 5.5. Like t1, you can say whatever you want to say. So find the difference and divide by the step length. So that's going to be 0.5 divide 0.1, which is a 5. So we need 5. The n should be a 5. Okay. All right. So the initial t value is 5. The initial x value is 1. And the initial y value is just 0. So everything is set and done. Let's execute, get the table. Now listen to this carefully. In your exam, you will be jotting down this table on your answer sheet. Like you will put a n over here, then you will put a t over here, the x and the y. So in this way, by putting in these values, you'll find the last column. Like in my case, I'll just give you the answer. So the x value is going to be 2.4545, 2.4545. That is the x value. And the y value is going to be 2.7352, 2.7352. Okay, so you can give your final answer as 3 significant figure and y equals to 2.74. Question 12. It's a 5-mark question. Tajinder believes that the number of cars arriving at an intersection every minute follows a Poisson distribution. Under this assumption, he decides to test the null hypothesis that the mean is 12.4 cars per minute against the alternate hypothesis that the mean is greater than 12.4. So before diving into the solution, I quickly want you to just know like what exactly is a Poisson distribution. So remember that a Poisson distribution models the number of times something happens in a fixed interval of time or space. Like I can give you an example, like number of people visiting a specific website per hour, or people coming to the restaurant every day on average, or like in this case, like the number of cars arriving in 1 minute. You get the idea, right? This is where the Poisson distribution jumps in. All right. So the test consists of observing the intersection for 10 minutes and then rejecting the null hypothesis if more than 130 cars arrive. Part A1, state the meaning of a type 1 error. Okay, now that is something worth noting as well. What is a type 1 error? So, a quick way to think about this question is a type 1 error like means rejecting the null hypothesis even though it's actually true. Okay, so that's the meaning. So let's just write this thing. Rejecting H naught even if it is true. This is known as the type 1 error. Okay, let's do part 2. Find the probability of type 1 error for Tajinder's test. So here the null hypothesis is the average number of cars is 12.4 cars per minute. And since the observation lasts 10 minutes, so this needs to be done like 12.4. This is per minute, so times it with 10 is going to be 124 for this part, right? So what does it do? The test actually rejects H naught if more than 130 cars arrive. So the probability of type 1 error is going to be greater than 130, right? Which obviously in a discrete distribution, just like Poisson is a discrete distribution, means 131. Now again, some of the calculators have a right side to this test as well, but mine doesn't. Like most of the Casio versions do it just like binomial for the lesser region, like less than equal to. So below 131 is going to be less than 130. How do we calculate this thing? Go to stats, distributions, and if you scroll to the right, you'll see the Poisson distribution over here. Go to the CD, and for the X, you will put 130. And for the mean, which is the Poisson's mean, is this lambda, 124. So let's just execute. I'm getting 0.7236, 0.7236. Let's get the full value, 0295, 295. Okay, so subtract it from 1. And let's see, what do we get? I'll go to the normal part of the calculator. 1 minus 0.723. 60295. I'm getting 0.27639 something. So I'm giving my answer 3 sig figure, 0.27639. 6. That's my answer. Okay, for part B, write down one reason why a Poisson distribution might not be a suitable model for the number of cars arriving at the intersection. So, one of the biggest problem with the Poisson distribution's authenticity is like you can never actually predict like exact fixed number of people visiting a hotel or maybe a website or like number of cars. So you can say that one simple reason Poisson may not fit is that the cars don't arrive independently. Traffic lights, maybe, or congestion can cause cars to arrive in groups. Like so, that is one problem. So, what should we write? Like, let's say we can write for B part that Poisson may not fit. I should have written Poisson distribution. Uh, since the cars don't arrive independently. So I think it's just a 1 mark question. So that's it. Question 13. It's a 9 mark question. The growth of a fungus on a dish can be modeled by a differential equation. And we can see the differential equation and P is within 0 and 1, where P is the proportion of the dish that is covered with fungus and T is the time in days from when the fungus began to form. Part A. Assuming that P is 0, when T is 0. So we have the initial or the boundary condition. This is used to calculate the constant when you integrate. Show that this thing. So we need to show this. So it's a case of a separable differential equation. It's part of the HL calculus. 0.2. We separated it, and now we're going to integrate. How do you integrate this? You can either use U substitution or the direct rule of natural log integration. You need the derivative on the top. So I'm going to be using the U substitution, so you can take some extra support from that. So let's say let U be a 1 minus P. So if you differentiate du over dp, that's going to be a -1. So negative dp. So I can say dp is a negative du. So let's put this in the expression, negative du over a u. So the right side is simple. That will integrate to 0.2 t plus c. So I'm getting from here, I will get a negative natural log of u. So u is nothing, it's just a dummy variable. So my answer will be the negative natural log of 1 minus p equals to a 0.2 t plus c. If you substitute uh, p0 and t0, natural log of 1 is 0 as well. So c is 0. So my final solution will be 1 minus p and a 0.2 t. Now keep an eye on like what you are trying to show. So we can see that they have made p the subject. So first we time both sides with a negative minus 0.2 t, convert to exponential form. So this goes into the natural log, natural exponential function, since the natural log, so base is e equals to 1 minus p, and hence p will be a 1 minus e to the power minus 0.2 t. Here we go. All right. So next part B, find the time at which the fungus covers 90% of the dish. So P is the proportion of the dish that is covered with fungus. So P is the proportion. So percentage, I can put part B. I'm going to solve it over here. 0.9 in place of P. 1 minus e to the power minus 0.2 t. So e minus 0.2 t is going to be a 0.1. So let's do the natural log thing. It's going to be natural log of a 0.1. So let's just use our calculator to get the natural log of 0.1 and divide it by a minus 0.2. So I'm getting 11.5 something. So you can say 11.5 days. Question 14. It's an 8 mark question. A plane needs to drop a relief package for a remote village. The villagers have marked out a point O in the middle of a field where the package should land. All right, so the package is released from the plane at the point A when it is a horizontal distance of d meter from O. We can see that this is where the package is released. The position vector of the package t second after release is given by the vector this, where x is the horizontal displacement of the package from O and y is the vertical height of the package above the ground. This is shown in the diagram. Okay, so this is the displacement vector. All right, so the question continues on the following page. Let's take a look at this. The acceleration of the package is given as this. So x double dot and y double dot. So this is a 0 and a negative 9.8 meter second minus 2. And its velocity at the point of release is given as this. So you can say this is the initial velocity, which is a negative 20 and a 0 meter second minus 1. Part A. I need to find the velocity vector. And obviously, you might be thinking that it's definitely it's a good way of thinking that this is just like a projectile motion, but we need to use calculus to get velocity. Why are we using calculus? Because think of it this way: if you have a displacement vector and you differentiate with respect to time, you get the velocity vector. If you again differentiate, you get the acceleration vector, right? Okay. So now, something worth noting is that horizontally, the acceleration is 0. So this must be the constant velocity, right? So you can say that x dot, we don't need integration for this. It's just like just a observation that it should be a negative 20. Why? Because the acceleration horizontally is 0. So horizontally, it's moving with a constant velocity, right? Vertically, however, it's falling or rising, like we know that the gravity acceleration is given. So we need to integrate the double derivative, which is going to be negative 9.8 t and plus c. So we know that at t is equal to 0, the initial velocity, look at this thing. Initially, y dot is a 0, right? So you will put y dot equals to 0, and this will imply that c is 0. So this way, y dot is going to be a negative 9.8 t. Hence, my velocity vector will look like a negative 20 and a negative 9.8 t, right? There we go. All right, so the vertical height of the plane above the ground at the moment the package is released is 70 meter. So we know that initially the vertical height x naught is given as 70 meter for part B. Find the value of D given that the package lands at O. So first of all, we need to integrate this function. So when we integrate x dot, we will get x. So that is going to be negative 20 t and plus c. Don't forget c. And we know that at time equals to 0, the initial displacement was given d, even in the diagram. So now the horizontal component of displacement will look like minus 20t plus a d by integration, right? And the vertical component, on the other hand, will look like, let's integrate, y is going to be a negative 9.8, a t squared divide 2, and plus c. How do we evaluate the constant? We know that initially, like, oh, sorry, that was a y dot. I made it x dot. I don't know why. So this was a vertical. You can check that the vertical height of the plane above the ground at the moment the package is released is 70 meters. So we know that y naught is 70. So if we put 70 and 0 over here, so c becomes a 70. So y is going to be a negative, what will that be? Let's check this out. So 9.8 divide 2. It's going to be a 4.9 t squared and plus a 70. So I've got my displacement vector, which will look like minus 20t plus d and minus 4.9 t squared plus a 70. This is the displacement vector. Okay, so the question says that find the value of D given that the package lands at O. So if the package lands at O, I shouldn't be writing on this page, but just because I want to complete my solution, so I'm writing on this page. The displacement becomes 0 because the package has landed. So From the y component, if you put this equal to 0, let's see what do we get. T squared is going to be 70 divided 4.9. And let's get this value. 70 divided 4.9 and square root answer. It's a 3.7796, 3.7796 t. And when I put the vertical displacement 0, I will get d equals to 20t. So d is going to be 20 times the 3.7796. I've got this answer feeded already, so I can just time it with 20. And this will give me the value of d, which is a 75.5928, 75.5928, approximately 75.6. This should be my answer. Question 15. It's a 6-mark question. A Markov chain has two states, A and B. The transition matrix for the Markov chain is given. One of the eigenvalues for this matrix is equal to 1. So part A says find the eigenvector corresponding to the eigenvalue of 1. So it's a broad topic, Markov chain. So I just want to quickly share something about it. Like you can say that the Markov chain describes the systems that move between different states according to certain probabilities. Here, the system can either be in state A or state B. The transition matrix tells us like the probability of moving from one state to another in a single step. So, like, look at this matrix. If you see that P is the probability of staying, let's say, in state A, then 1 minus P will be the probability of moving from A to B. And similarly, if Q is the probability of staying in state B, then 1 minus Q is going to be the probability of moving from B to A. And another thing, like in this part, like it says the eigen value is equal to 1, right? So the eigenvalue of 1 is important because its corresponding eigenvector represents the steady state distribution, meaning like the long-term proportion of the time spent in each state after many transitions. So you can rewind and listen to that again, and you can go over these ideas again, right? So if you want to revise, you can revise them again, okay? So part A, let's take a look at this. How do we find the eigenvector corresponding to the eigenvalue 1? So let's say the transition matrix is M, okay? So that's a P, 1 minus P, 1 minus Q, and Q. And we know that the situation tells us that M times a vector V will be lambda times V, but that's just a 1, so that's V. So let V be XY, and we can play around with this to calculate the eigenvector, right? So they're saying find the eigenvector. So I'm going to multiply P and 1 minus P and 1 minus Q and Q, XY, and put it equal to XY, right? Okay, so this will become Px plus 1 minus Qy equals to X. And the other thing will be 1 minus Px and plus a Qy equals to Y. I can solve any one of them to make an equation. So Px minus X, I'm using the left one, plus a 1 minus Q times a Y equals to 0. If I take X common, I will get P minus 1 plus a 1 minus Q, Y equals 0. So 1 minus Q, if I make it Y, and when it goes to the other side, let's make it 1 minus P and X, right? So this way I can get X over Y equals to 1 minus Q over 1 minus P. So I need my vector XY that will look like 1 minus Q over, sorry, not over, 1 minus P, right? So we can write the eigenvector like this, okay? All right, so let's take a look at part B. Hence find an expression in terms of P and Q for a proportion of the time segment in state A. So it's talking about time segment in state A. The steady state probabilities are found by turning the eigenvector into probabilities that add up to 1, right? So for I can do the part B over here, let's say. For part B, I need to add the probability. So that's going to be 1 minus Q and 1 minus P. Some courses say like normalizing it. Okay, so this is the total. So it's talking about A. Probability of being in state A will be, so that's 1 minus Q over 2 minus P minus Q. That will be my answer for part B. So in the C part, they're saying, hence or otherwise find the proportion of time spent in state A when P is this and Q is this. So that is a simple question. We just need to sub in the values and calculate. It's just a 1 mark question. So I'm doing it here. Sorry about that. You know that I'm just saving space. So 1 minus Q is a 0.6 over 2 minus a 0.3 and a 0.6. So let's just find these out. So I have 1 minus a 0.6. That's going to be a 0.4. Okay, and I will get a 2 minus a 0.3 and a 0.6. That will be a 1.1. So I'm getting a 4 over 11 for part C. Question 16. It's 8 mark question. The graph of f is defined by f of x. 4 cos pi x over 8, 0 to 4. The graph of y equals gx is formed by translating the graph of f 0.2 units to the left and 0.2 units down. The graph of g intersects the x-axis at a0. You can see that, and its domain is then restricted to 0 to a. These curves are shown on the following graph where units are in centimeters. Part A, write down an expression for g of x. So I'm going to do my part A over here. So g of x will be written as 4 cos, let's put a pi over 8, and instead of the x, I put x plus a 0.3 and minus a 0.2. So in function transformation, you know when something is moving left by 0.3, in the function you write a plus 0.3, and for downwards it's just a minus 0.2. So if you have not revised the function transformation properties lately, you should. Let's do the part B, find the value of A. So for value of A, you need to set your function equal to 0. That is one way. But I think this is a good way. Like you can just go to graph and just substitute this function for cos. Let's put a shift pi x plus a 0.3 and divide 8 and minus a 0.2. Let's see. So I'm getting a graph like this, you can see. So I need to find the root, but this one, the positive one. So this is 3.572622. 3.57, oh, it's a big value. 26229. 26229. And approximately this should be 3.57, the value of A. All right. Let's take a look at the next part. They're saying a wall-mounted light shade can be modeled by a solid formed when the region between the two curves R is rotated through pi radians about the x-axis. Part C1, write down an expression for the volume of the solid formed. Now, there is something worth noting. The formula given in the formula booklet is like a complete rotation about the x or the y-axis. So we write the pi, like I should write it, if this would have been a full turn, this would have been 0 to 4, and the function, which is a 4 cos pi over 8x and whole squared dx. This is the outer volume. But look, since it's just a pi about the x-axis, so you will put a pi over 2. So keep in mind, like this thing, it's a half turn pi about the x-axis, not a 2 pi about the x-axis. Okay? And since it's a hollow volume, there's an inner thing as well. You need to subtract that bit. So pi over 2 again, but this time it's going to be 0 to 3.5726229. and 4 cos, and that whole function that I just typed in, pi x plus 0.3 divide 8 and a minus 0.2. Oops, I'm running out of space. Yes, but you get the idea. In the answer space, you can write the whole function squared and within the limits and just time it with a pi over 2 due to the pi radians turn through the x-axis. Okay? So now we need to evaluate this. Oh, these are tricky to put in your calculator, but let's try. And first of all, if you're using your Casio GDC, make sure your setting input mode is on math, not line. Okay? Because that can cause some serious problems. Okay, so I'm going to evaluate the inner integral. I go to option, calculate integral. So let's feed in the limits, 0 and a 4. And now I put my function, which is a 4 cos. Oh, I need to put the bracket since I want to square this. 4 cos. And let's put a shift pi x and divide it by 8. And now I'm going to square this thing. And well, let's go. It's 32. So let's take pi over 2 common for the second part. And the inner integral is now 32. Now I need to feed in the second integral, right? So let's just, maybe we can rewrite the new integral, right? Okay, so option, calculate, integral. Limits are this time 0 to, let's put in the whole thing, 3.5726229, just to be on safer side. Okay, now I put my function, which is going to be a bit tricky. Let's hope this works out. Cos, put a bracket, shift pi, bracket, x plus a 0.3, bracket close, divide the whole thing by 8, and minus a 0.2 as well, and now square it. Okay, let's see. So I'm getting 23.77289. 23.77289. Okay, so I've got my values, 32 minus the answer. And time this whole thing with a shift pi and divide it by 2. So I'm getting 12.9231, 12.9231. So 12.9. That should be my final answer. And that's it for this whole exam. I hope you learned something from it. I would encourage, if you were not able to watch the whole video, you can always rewind, save, and redo these questions. There's plenty of important stuff going on in this exam. And if you want to be good, fluent with your IB application math, you should keep practicing and do visit for more useful resources in the future. This is Global Math Mentor, over and out.